Hi guys, today's lesson is on central tendency again. So this isn't something entirely new. We've already talked about mean, median, mode, and range. So hopefully it is a good review and you find it easy. It says in our day-to-day activities, we deal with many problems that involve related items of numerical information called data. Statistics is the study of sets of such numerical data. When we gather numerical data, besides displaying it, we often want to know a single number that is representative of the data as a whole. We call these types of numbers measures of central tendency. The two most common measures of central tendency are the mean and median. Alrighty, exercise 1. A survey was taken amongst 12 people on the number of passwords they currently have to remember. The results, in ascending order, which just means they already put them in order from least to greatest for us, are shown below. State the median number of passwords and the mean number of passwords to the nearest 10th. All right, so we have to remember, mean is just another word for average. So mean just means average, whereas median stands for the middle number. And it does have to be in order from least to greatest, but again, they've already done this for us. So since they asked for the mean first, or did they? They asked for the median first. Let's do the median first, might as well. All right, so to get to the median, I personally like to cross out at the beginning and then the end until I get to the middle. So I just take turns going back and forth, back and forth. Because if I kept crossing, I wouldn't be left with any numbers. I have to keep those two and average them. So I'm going to do 2 plus 3 divided by 2. And 5 divided by 2 is 2.5. Okie doke. Then we're going to find the mean. So remember, for the mean, we add up all the numbers there. So we would do 0 plus 1 plus 1 plus 1 plus 2 plus 2 plus 3 plus 3 plus 3 plus 3 plus 4 plus 6, all over the total amount of numbers there, which is 12. When you do that, when you add all those up, you should get 29 over 12, which reduces to about 2.416. But remember, it said to the nearest 10th. So the 10th place is just one decimal. So since a 1 comes after the 4, I'm not going to round up. I'm just going to leave it 2.4. So our median, number of passwords is 2.5, whereas our mean is 2.4. Okie doke. Exercise number 2 says, students in Mr. Okafor's algebra class were trying to determine if people speed along a certain section of roadway. They collected speeds of 20 vehicles, as displayed in the table below. So again, we have talked about this before. This is called a frequency table. And since they said 20 vehicles here, when you add this up, the number of cars should make 20. So what this is basically saying, and I'm not going to list it all out, but I will say some of it. It's saying one car went 29. It's saying 2 cars went 33. So if they would have listed this out in a list instead of as a table, it would have looked something like this. 4 cars were going 34. And you should be getting the point by now. I could keep listing them all out. Okay, so it wants us to find the mean. Well, I have to add all those up. And I can't just do 29 plus 33 plus 34 because there's 2 33s and there's 4 34s. So an easy way to do this is just use multiplication. I know one car was going 29. So 1 times 29 plus 2 cars were going 33. So 2 times 33 plus 4 cars were going 34. So 4 times 34 plus 5 cars were going 35. 3 cars were going 36. 2 cars were going 38. 2 cars were going 39. And 1 car was going 54. And I would divide all that by the total number of cars, which remember was 20. So what you're going to want to do is put this entire thing into your calculator. You should get, let me use my cheat sheet here, 722 divided by 20. What do you get when you do 722 divided by 20? You should get 36.1 miles per hour. So that's the average, or the mean is 36.1. All right, now I need to find some space to find the median. So the median is the average. Goodness me, the median is that middle number. So if you want it, you could take the time to list those all out like I was starting to do up here. We could also take some time to just think about this. We know there's 20 vehicles, so this would be the first vehicle. There's 2 here, so this would be the second and third. There's 4 here, so 4th, 5th, 6th, and 7th. There's 5 here, so that'd make up 8, 9, 10, 11, and 12. There's 3 here, so that's car 13, 14, and 15. There's 2 here, so 16 and 17. 2 here, 18 and 19. And this would make car 20. So then you could either think about it and think, well, the middle of 20 is going to be, between 10 and 11. Or you could do the cross out thing if that makes you feel better. You could cross until you got to the middle. And you would be left with 10 and 11. Well, car 10 and 11 are at 35. So even if we did 35 plus 35 divided by 2, you would still get 35. So the median is that they were driving 35 miles per hour. So part B says the speed limit along this part of the highway is 35 miles per hour. Based on your results from part A, is it fair to make the conclusion that the average driver does speed on this roadway? And I would say no. For one, our mean was 36 and our median was 35. And you can see that if we look at the data up here, how many people were going 35 or lower? Well, that's 12 people out of 20. So if 12 people out of 20 are not speeding, and if we do 12 divided by 20, that's 60%. So more than half were not speeding. So 60% are not speeding. So I would make the assumption that it's fair to conclude that the average driver does not speed because 60% or 12 out of 20 are not speeding on that highway. Something to note, 54 here is a major outlier. We would call 54 an outlier. It's nowhere near the other numbers. You're going to see when your data has an outlier, it truly affects your mean. It will never affect your median, but it will affect your mean. So that's why the mean is a little bit higher than the median. All right, go ahead and flip it on over. It says, when conducting a statistical study, it is not always possible to obtain information about every person or situation to which the study applies. Unlike a census in which every person is counted, you may see where you live, your parents or whomever you live with might get a census every now and again. And they literally send that out for everybody to answer the questions. But some studies only use a sample or a portion of the items being investigated. Wherever a sample is taken, it is vital that it be fair. In other words, the sample reflects the overall population. So you might only be picking a small amount of people or whatever your sample is you're talking about, but that sample needs to be fair. It can't be biased. So for example, if you're trying to figure out who likes baseball, you're not going to ask people at a baseball stadium because most likely they like baseball. That would not be a fair representation. It would not reflect the overall population. So exercise number 3 says, to determine which television programs are the most popular in a large city, a poll is conducted by selecting a sample of people at random and interviewing them. Outside which of the following locations would the interviewer be most likely to find a fair sample? Explain your choice and why the others are inappropriate. Okay, so if we picked a baseball stadium, we need to think, would that be a fair sample if we're collecting which television programs are the most popular? So if you're at a baseball stadium, you most likely like baseball or even sports. So I feel like that could be biased because they most likely like to watch sports on television. 2 says a concert hall. So obviously that has something to do with music. So that could potentially be a little bit biased as well, because that might favor more like the musical, like artsy kind of people. A comedy club is obviously people who enjoy comedies. So that would probably lend itself more towards like a comedy type show. Whereas a grocery store would probably be the most fair because everyone goes to the grocery, right? There'll be different races, there'll be different genders, there'll be different ages there. They like different things. It's not geared towards one interest. So a grocery store would be most fair. Exercise number 4 says, Churong is trying to determine the average height of high school male students. Because he is on the basketball team, he uses the heights of the 14 players on the team, which are the given below in inches. Calculate the mean and median for the data set. Round any non-integer answers to the nearest tenth. So again, that is 1 decimal. All right, so to find the mean, I'm going to kind of abbreviate this. I would do 69 plus 70 plus 72, and you can do this little thing. You can do plus, dot, 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 plus, and go to the very end. Just showing your work that you are adding all of these up, but we're just not taking the time to list it out. And there's 14 numbers there. So when we add all of those up and we divide by 14, you do get that the average or the mean height is 74.6 inches. So that is the mean. Now if I do the median, again, that is the middle number. So I like to do the little crossy thing. I'm going to cross until I get to the middle. I am left with 2 numbers, so I'm going to have to add those up and divide by 2, and you get 74.5 inches. So that is our mean and our median. All right, it says, is the data set above a fair sample to use to determine the average height of a high school male student? So I would say no, absolutely not, because a basketball player tends to be taller than most average high school students. So a basketball player tends to be taller. I mean, doesn't have to be, but tends to be taller than the average male. So this is not a fair sample to use. All right, data sets can have members that are far away from all of the rest of the data set. These elements are called outliers. So we've talked about this a few times, which can result in a mean that does not represent the true average of a data set. And this is important. This is something you actually do see on your EOC. So I would definitely pay attention. That's really important. When you have an outlier, your mean is not as accurate. It doesn't represent a true average. All right, it says in Mr. Petrovic's advanced calculus course, 8 students recently took a test. Their grades were as follows: 45, 78, 82, 85, 87, 89, 93, and 95. So it says to calculate the mean and the median. So for my mean, I'm going to do 45 plus 78 and so on, and I'll add it all the way up to 95, and then I'll divide by those 8 numbers. So when you do that, you get 654 divided by those 8 test scores, and you get that the average is about an 81.75. So that is for your mean. When we do our median, or the middle number, let's see, we cross, and we have to average. So we're going to do 85 plus 87, figure out what that is, and then divide it by 2. And you should get 86. So that is our mean and our median. Part B says, what score is an outlier in this data set? So you're looking for the number that is not as close to the other numbers. And you should see that 45 is not close. The rest are in the 70s, 80s, 90s. So 45 is definitely an outlier in this data set. It says which value, the mean or the median, is a better measure of how well the average student did on Mr. Petrovic's quiz. All right, so I would say the median, because it is not affected by the outlier. And here's what I mean. Again, this is huge for your state test. You'll for sure see a question about this. And you can always change numbers around to help yourself. So we said that this 45 was the outlier. Well, let's just say I change that to 75. So instead my data read this, 75, everything else stays the same, 78, 82, 85, 87, 89, 93, 95. And I said with the 45, my median was 86. Well, look what happens when I find the median again. Cross, 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 cross. Look at that. I'm left with 85 and 87 again. When I find the middle, the average, I get 86. So changing that outlier did not affect the median at all. So this is a better representation of what our average truly is, because that outlier can't pull us down. Let me show you what happens if that outlier wasn't there with the mean. So we said initially with our initial data, our mean was 81.75. Let me find the mean with this new set of fake data I'm using up here. So if I were to add all those up, let's see here. I haven't done this yet, so give me one sec. 75 plus 78 plus 82 plus 85 plus technical difficulties. Why is that not working? 82 plus 85 plus 87 plus 89 plus 93 plus 95. I get 684 divided by the 8 scores that there were, and you get an 85.5. So look how much my mean changed. It's almost an 86, and it was an 81, almost an 82. So it changed drastically just by making that outlier that was there closer to the data. So an outlier will really affect our mean. So if in your set of data you ever have an outlier, your median is always the best number to truly represent the average of whatever you're talking about. So I believe that is it. You can go ahead and work on your assignment now. And if you have questions, be sure to let us know. For your assignment, you are going to do your work on your paper, but you're also going to answer your questions on this ed puzzle. So question number 1 says, the student government at Arlington High School decided to conduct a survey to determine where to go on a senior field trip. They asked students the following question: would you rather go to a sports event or to an IMAX movie? At which of the following locations would they most likely get a fair sample? 1, the gym after a game. 2, the auditorium after a play. 3, a randomly chosen study hall. 4, at the nature club meeting. Number 2, for the following data set, calculate the mean or the average and the median, the middle number. Any non-integer answer should be rounded to the nearest tenth, so that is 1 decimal point. Number 3, for the following data set, calculate the mean and median. Any non-integer answer should be rounded to the nearest tenth. Which of the following is true? Number 4, which of the following is true about the data set? 3, 5, 5, 7, 9. 1, the median is greater than the range. 2, the median is equal to the mean. 3, the mean is greater than the median. 4, the median is greater than the mean. Number 5, which of the following data sets has a median of 7.5? Number 6, a survey is taken by an insurance company to determine how many car accidents the average New York city resident has gotten into in the past 10 years. The company surveyed 20 people who are getting off a train at a subway station. The following table gives the results of the survey. Part A, calculate the mean and the median number of accidents of this data set. Remember, there's 6 zeros in this data set, 8 ones, etc. B, are there any outliers in this data set? If so, what data value? C, which number, the mean or the median, better represents the number of accidents an average person in the survey had over this 10-year period? So I would again think about things we talked about in the notes. Do you have an outlier? And does the outlier affect the mean or the median? It does affect one of them. So which would be the better representation? Part D, does this sample fairly represent the average number of accidents a typical New York City resident would get into over a 10-year period? Why or why not? And E, construct a dot plot that represents this data set on the axis below. So you will do this on your paper. And then you're going to answer, is this a symmetric plot? Explain your thinking. Be sure to turn in your notes and your homework before you leave today.